Hi everyone. So in this video, I'm going to talk about how we actually can transform the parent function of square root to get this y equals 4 times x minus root x minus like square root of x minus 3 plus 2. Okay, by transformation. Okay, so like before we do, like I like to kind of draw the parent function for sure, just to see how this is going to relate to each other. So let's go ahead and do that. As a general approach, we know we just have to have some points in order for us to sketch any graph. So which is why I like to have some points. So if I want to start with the zeros, that will be 0 as well, square root of 0. And if I want to go with 1, that will be 1. So that will be the second point. If I want to choose 2, it's okay, but I don't want to deal with the fractional stuff or decimal. I like to choose x is like 4. So square root of 4 will be 2. So that will be another point. Maybe I can go with 9. So that will be 3. So you have already 4 points, which is enough, I guess. So that will be 1, 0, 0. And then that is 1, comma 1. And then we have 4, comma 2. So that will be somewhere right there. And 9, 3. So that should be something right there. So with your best ability, so you can connect those points to make a nice curve, okay? So it's not perfect, but it's okay. This is the y equals square root of x, which is our parent function of the square root, right? So now we like to uh, graph this one by using some of the transformation features. But to do so, I'd like you to go ahead and explore the Desmos and each like effect of the numbers in this equation, which is why I just have actually general form right here. So I'd like you to plug these points, this equation in your Desmos or any calculator, and make some slider and then A, H, and K, and see how each of those like variable affect it in your graph. Okay, so which is something I assume you just did it or you have good experience with that. Otherwise, this might be a bit challenging. So I will highly recommend you to do so. Okay, so that is the one of the forms that we have of the square roots. Okay, and then in this form we do have a couple changes, couple effect of the transformation. So the first things first that we have to remember, the h, which is inside of the square root, is actually a horizontal shift. So whatever we have a number after this minus, which is h, is gonna move the function to the right or to the left. So if h is like 5, which means, let's say if x minus 5, then you are gonna move the function 5 units to the right. If h is -3, which means x minus -3, which is x plus 3, then that will move to the left by 3 units and stuff like that. Again, that is something I'd like you to explore on your own for sure, but that's just a reminder for now. And then k will move our function, translate the function like k units up or down. So in this case, 2 units up, okay, because it's a positive and stuff like that. And then same thing, the effect of this for I'd like you to do on your own as well. So that is something I'm assuming you have somehow background, okay? And then now we like to see how the parent function will help us to get the graph of this guy, right? But to do so, I'd like to remind this as well, which is not something you have to memorize, but it's good to know. This is also a result of those like basically exploration with those graphing, so which is something will take time. So that the 0, 0, which is kind of vertex right here, is gonna move to the h comma k. H will be the number after the minus inside a square root, and then k is the number after the square root. So that will be our new vertex. So in that case, right here is like 3, and this is a 2. So that will be actually our vertex, 3, comma 2. So if you remember this one, so 0, 0 will actually map to h, comma k. So 3, comma 2. You can always plug it right here, because if you plug 3 for h, actually really that will give us like 3 minus 3, which is 0. So 4 times square root of 0 is just 0. 0 plus 2 is 2, which will give you 2, which is good to know. So, okay. And to confirm, and then 1, comma 1, whenever you have 1, comma 1 right here, that point will map to h plus 1. H is the vertex, the new vertex, the x coordinates. It will increase by 1 because this is by 1. So that is kind of common sense. And then the y value will change a bit different because the number 4 right here will actually affect your y value. It doesn't affect the x, but it does affect your y value. So you will add the k to a. Okay, a is the number 4 right here, so which will be, if you choose like 1 comma 1, so you will get like h was 3 plus 1 is 4, so you get 4. And then k plus a, k is 2 in our case, a is 4, which is gonna be 6. Again, if you don't see that, you can always I don't know, choose some random points that will make nicer. But it doesn't help you in general. It does help you in graphing for sure, because you just need to plug some points and get the graph. But that's why it is good to know this one. Sometimes this is gonna be only shot, so which is you have to deal with. And as soon as we have those two critical points, like 0, 0, and 1, 1, just move to these 2 points. Then you can have more points by just randomly choosing, okay? But when you're choosing those, try to choose something that will make your life less miserable, so you can kind of deal with the square root. So like this guy was 1 when x is 4, so this guy will be 4 if I choose x is 7. So then I can choose next number as 7. So 7 minus 3 is 4, square root of 4 is 2, 4, 2 is 8, 8 plus 2 is just 10. And then we got that. And then I like to get the square root of this inside to be 9 now. So that will be 12 for x, right? 12 minus 3 is 9. Square root of 9 is 3. 43 is 12. Plus 2 is 14. So we do have 4 points, which is enough. So we don't really need more than that. So the first point is our vertex, 3, 2. So that is 3, 2. It's going to be something right there. And be aware that since this number is like 4, I didn't really have to deal with anything like flipping the graph over the y equals like 2, because this guy will be like, this point will be my vertex, and then y equals 2 will be line. I need to flip if I have that a to be negative, okay? Just keep that in mind. And 4, 6, so that will be something right there. And then 7, 10, so 7 will be right there, that's 10. And 12, 14, so that is 12. So again, this is 12, 10, and then there will be 12, 14. So again, it's a bit harder at this point, so because of the scaling, but it will be something like that. You can always confirm that by plugging these function into a, I don't know, graphing calculator, so to see if that's the case. But my goal in this video is just to show you how we can actually graph it without a calculator, if that is something we are asked to do so, okay? But in that case, we like to see how each variable, which is we call like parameters of the function, is affecting our graph, okay? So that is something we have to remember, so that's why I like to use those. And then there is another form of this square root, so if there's a number in front of the x, so that will have something different effect, so which is something a bit challenging. So that's why I wouldn't memorize all these things. I really need to understand how each number, like in those equations, affect my function. So as soon as we discover their effect, then it will be way simpler as we go. Okay. So anyway, I'll see you in the next video.